This is the Pearson Edexcel IGCSE Further Pure Maths from November 2021. It's paper number 2, which is calculator because they're both calculated because I don't know. This is the formula in the formula book. There it is. So therefore, cos of, if we just replace b's with a's, cos of a plus a is clearly cos of 2a. And that's how we're going to make our start. But cos of a plus a is cos a minus sine a, which is cos squared a minus sine squared a, which is 1 minus sine squared a minus sine squared a. And then, of course, it's going to be 1 minus 2 sine 8, which is the right-hand side. You'll have seen this before. They ask it every single paper. It's great. Anyway, given sine of a is this and cos of 2a is that, show this thing here. So, of course, I'm going to use this result here. So I want a sine squared. So let's square both sides here, and we'll get this. 2 squared is 4. We'll times it by 2 to get this bit. We'll do 1 minus this to get this. And now I can just take this result here, because it's the same as this, and put it in here. So I get cos 2a equals all of this. But cos 2a is that, so we can get those two things there. Now there's just a bunch of algebra to do. It's not too difficult. Times by 3, I guess. Expand all this out, I guess, or put the y over here and put all of this over here is maybe what I did. And then 4 minus 3 is 1. And you get this, and then you can expand everything out finally. I think I also doubled everything just because, yeah, now expand this out, I guess. Finally, get this, then divide by 2. And we end up with what they wanted us to get. So just some algebra there. So let's sketch this. 4 minus x squared is a quadratic that has y is up to 4 and is symmetrical like this. And x plus 2, well, 2 is halfway to 4, so it winds up as here. Also, when x is minus 2, y is 0. And also when x is minus 2, y is 0 here, so they connect there at minus 2. And also at 1, I think is the other point, because 4 minus 1 squared is the same as 1 plus 2. So, okay, we're going to find this area here, but we're also going to rotate it around the x-axis. So we can do the integral, or pi times the integral of y squared for this curve between minus 2 and 1. And then take away pi times the integral of this y squared between minus 2 and 1. Now, of course, we could also just do this integral, and then when you rotate a line, you just make a cone. So then you could just look up the formula for a cone and say the height is 3 and the radius, I think, is also 3, because this is 3 here, and do that. But I decided to do it like this. Of course, when you're doing two integrals with the same limits, you can just put those together, which just, I don't know whether it even makes it any faster. Expand out both those things and then collect together some terms, and then you've just got some very basic integration to do. And put in the numbers, put in pi, and everything like that, and we end up with this eventually, and we're good to go. Question number 3 then, so, well, x cannot equal d over c, and this asymptote is x is 3, 2. So therefore d is 3 and c is 2, clearly. You can also, I mean, sure, you're essentially just saying that this thing needs to be 0, and then you just solve that for 0, but you know you need to get 3 over 2 from that. So you just end up having to use 2 here and 3 here, because when you add 3 divided by 2, you get this. Yeah, whatever. I can't bother going more in detail about that. This means that when x is this, y is this. So let's substitute that into our result here. And of course, this doesn't matter because you could just times it over there, and 0 times anything is 0. So we just get 0 equals this thing here. Times the thing by 4, and then it's pretty clear that a could be 5 and b could be 4, because 4 times 5 minus 5 times 4 is 0. So we'll get those two numbers there as our options. Anything else makes a not prime, which it needs to be. So good, we have that. And then what else do we have? So we know that we go through, just make that a bit better. Now we have those two results as well. We know it goes through 0p, so when x is 0, y is p. When x is 0, you get 5 minus 0 over 0 minus 3, so y is 5 over minus 3, which is minus 5/3. So that's what p is. And then the equation of this asymptote here, well, this is a little bit harder, but the general rule is it's just this x coefficient divided by this one. Minus 4 over 2 is minus 2, and that's the asymptote equation. The reason for that is because if you try and use y as minus 2 in here, so like if we make y as minus 2 and try and look for the x value that actually gets that, when we multiply across here, these two coefficients now match, which of course means when you add add 4x to both sides, you get into certain difficulties. So that'd be why that works, and you can prove that algebraically, that just this divided by this is always going to do that. But anyway, we have our answer there, and we're pretty much done. So now we have this equation here, we've got a stationary point here. So if we find out dy by dx, is, we can just do that as soon as we read stationary point. Stationary point is dy by dx equals 0. So we'll set that to be 0, and we know it's 0 when x is 3. So we'll shove x as 3 in, and we'll get p as minus 12. So that's fine, that's that done. If this is a stationary point, though, this also means that the curve has to go through it, because it's a stationary point on the curve. Let's just put these two results into here, but you now already know p. You know p is minus 12, so you can put that result in as well. And this is enough to solve for q, and we end up here. State the nature of the stationary point, we'll just find out d2y by dx squared, and that's positive, which means it's a minimum for any value of x. It doesn't actually matter that x is 3. You could also just say this is a quadratic, so it's a U shape, which, because it's positive here, so it's clearly just got a minimum. I think that will probably also get the marks. Anyway, find an equation for the normal to c where x equals 1. So when x equals 1, the gradient is 4 times 1 plus p, which is 4 times 1 minus 12, which is minus 8. The normal is going to have the negative reciprocal gradient of this, that's going to be positive 1/8. Now we can just use y minus y1 equals mx minus x1 for the equation, the normal. We just need y1, and to get y1, we'll just put x is 1 into here with our p and q results that we already found. So 2 times 1 squared is 1, sorry, it's 2, plus minus 12 is minus 10, plus 13 is 3, so y is 3. So now we just have y minus 3 equals an eighth x minus 1, and that's going to be the equation of the line. In this form, though, times it by 8, and then do a bit of rearranging, and we end up with our answer just there. Question number 5 then is kind of an interesting question. So x increases by 3%. So the little change in x is just 0.03x. So it depends on what x is, because of course it's just taking a percentage of whatever x is. And of course it's tempting to say 1.03x here because it's increased by 3, but that would find the final amount, not the change, right? It's just changing by a little bit, and it's changing by this much. It's changing upwards, and it's going to add on to the original thing, but that doesn't matter to us. The little change in x is just 0.03 times x. Now the change in y then, well, to get this, what we need to do is we need to find dy. Now the best we can do is find dy by dx first. So find dy by dx, this is just product rule, isn't it? So differentiate that one, and which just goes to 1, and leave this one alone, and then leave this one alone, and differentiate this one, which is a minus 2 e to the minus 2x, so we get this. Now, of course, we can multiply the dx over to the other side because we can pretend this is a fraction. And then dx is this, so we can substitute that in. We can also factorize out e to the minus 2x to get this. And now, if we're so this is dy, this is our little change in y. And it's tempting to think that this is a mess and it's not very helpful at all. But it wants, really helpfully, it wants an estimate for the percentage change in y. And of course, to work that out, you do the difference, which is dy, divided by the original amount, which is y, times 100. Right? That's the percentage change in y. But of course, when you do dy over y, when you do this over this, all the bad stuff's going to cancel. This with this, this with this, and we're just left with this, this, and this. 100 times this is 3, and we'll just be left with 3 into that, which is the form they want. So that's quite nice, and we're done. Question 6 then, so find the distance from O when t is 0. So when you put t is 0 in here, you get the distance is minus 8, but that's not a distance, so we'll just say distance is positive 8. Find the value of t for which p is at rest. So v, which is the velocity, is ds by dt. So we'll do that, we'll just differentiate. And then at rest means v is 0, and then we'll just factorize this. And we'll get solutions at minus 4 over 3 or 4. But of course, time can't be negative, time always marches on. So we'll just have t is 4, and that'll be that done. And then a is dv by dt. So dv by dt is just this differentiated, which is this. And it tells us a wants to be 10, so we'll make it 10. And then we'll solve this and we'll get t is 3. And we are done. Good, that was a nice quick question. A lot of, if you haven't seen them, I do a lot of videos called Tamura, and this question comes up. This exact question comes up a lot in Tamura, so I'm pretty practiced with it. You've got some information about geometric series in here. If you want to practice more of these types of questions, actually just do some Tamura papers, or find some questions like these ones, because they're good. They're very similar. Anyway, the first 3 terms is this. So we're doing geometric here. So 61 over 6, which is the sum of the first 3 terms, is just this, where n is 3. I don't know a or r, so I'm just going to put those in there. Sum to infinity is this. So this is 125 over 6, and then I don't know either of those things, so I'll just leave it there. Now, the best way, or cleanest and most clinical way of dealing with this is just to put this 1 minus r cubed down to the side for a second, and then replace this thing here with 125 over 6. Cancel the 6's, divide by 125. Do 1 minus this to get r cubed, which is this, and then cube root to get 4/5. And then find the value of a. You can just put 4/5 in here. 1 minus 4/5 is 1/5. And then times everything by 1/5, I guess, to cancel this out, or to get rid of it. And you eventually end up with this, which cancels down to, I believe, this. The sum of the first n terms is this, given this thing here. So the sum of the first n terms, just using this formula here, has got to be bigger than that. So we'll just put in this thing here with a and r as the values that we know, and say that needs to be bigger than this. This is 1/5, times it across over here like we did last time, and we get this, apparently, just working in fractions. Divide by this thing here, and we eventually apparently get this. 1 minus this, I think I put this on the other side, and then put this over here to get this, which is good. We've got some numbers that we should recognize. I don't even know what log this is because I haven't read the specification for this paper. I assume it's log to base 10. I honestly have no idea. We don't use this notation. But PowerPoint accepted it, so I'm just going to use the same thing they did. I have no idea what base that actually is. Oh no, I must do, because later on, I think I said it was 10, and that gave me a reasonable answer. Although, does it actually matter? Would it cancel out? Interesting, I don't know. I think it's log base 10. It must be, right? Otherwise, they would just write ln. I'm sure they've done that in this paper. Anyway, I digress. We end up with this thing here, which is, oh, bring the end down, and then you get exactly what they wanted us to get. Now, just be careful at the very end here, because when you divide by log 4/5, assuming this is log to base 10, which it must be, right? It must be. Log to base 10 of 4/5 is negative, so when you divide by it to bring it over here, this sign swaps, and you get this, which makes a lot of sense, because, of course, if we're looking for the least value of n has to be bigger than something. So then you type this in, you get this, and n has to be 14 or bigger for your final answer. And yeah, that must be log to base 10 then. Eventually I'll figure it out. That must be what I typed. Anyway, 2 marks apparently for doing some year 7 substitution with a calculator, so that's great. On the opposite, and then 2 more marks for plotting some points and then drawing a line through them, which in PowerPoint is quite difficult. And I just said that, and that was the best I could do. And then this bit actually involves some work. So essentially what you want to do is make the algebra that you get given this algebra. Like just by any means necessary, make this algebra this algebra. I don't care what you do, just make it this algebra up here. So first let's divide by x squared. 0 divided by x squared is 0, 0. And then of course that makes this match with this, that's good. Now I'm going to take away 2x from both sides to make this match. And I'm going to add 7 to both sides to make this match. And we end up with this, which is great, because that's the graph that I drew over here. And now what this is saying is that this question here is equivalent to this question here, because of course what I've done is like unsimplified some algebra. But this question here is saying, when does this graph here intersect this graph here? And I can draw this graph. I can just say this is a y ends up to 7, gradient -2, so that's going down 2 across 1, down to there. And intercepts are at maybe 0.6 and 2.3 or something like that. And our answers are done. Good. Question number 9 then involves a pyramid. The 1, 1 root 2 triangle exists, so therefore this is the 10, 10, 10 root triangle. 10 root 2 triangle, I should say. Now this is, maybe you need to use a bit of logic here. It wants us to work out this length here to the midpoint, where this is 5 root 2 just over here. Now the answer is 5 root 2. There's a few ways to demonstrate this. I don't think you have to do any of them, since there's only 2 marks. I think you've just wrote down the answer, that'll be enough. But you can imagine this being a square on the bottom here. And of course, if it's a square, then this diagonal goes through to the other diagonal, which means it meets it at 90 degrees here, because of course it's all symmetrical. It must be 90, 90, 90, 90. So this is 90 degrees. This is 45 because the original thing is an isosceles triangle. I mean, there's probably lots of other ways to obviously, demonstrate or argue this. But in any case, this makes a smaller isosceles triangle of 45, 45. And therefore, if this is 5 root 2, which it is, because this is the midpoint, then this is also 5 root 2. Anyway, there would have been lots of ways to justify that, but that is beta m. Given that BD is 6, that's there, find the size of the angle between the plane at the back here, CDA, and the floor, ABC. So that's going to be, if you draw a line down here, that's going to be this angle over here. So if we just say this is 5 root 2, as we said before, and this is also 5 root 2, look at these 2 triangles on the back of the picture. We've got diagonals of 8, we've got sides of 5 root 2 and 5 root 2 here, got a shared side. So these are congruent by SSS, which means that these 2 angles here must be equal, because the triangles are equal, so there can't be any imbalance here, which means this must be 90 and this must be 90. But if they're both 90, then therefore I can just do Pythagoras to find this length by doing 8 squared minus 5 root 2 squared, all square rooted, which is root 14. So that's this length here. Now look at this triangle here, and I'm looking for theta. That's that theta there. That's the angle between this plane at the back and the plane on the floor. And of course, I can just do some cosine rule to find this. Ignore this arrow for now. It's not necessary. We'll get to it later. I can just do some cosine rule to find this theta here. You don't even have to do that much working because you've got a calculator, so it's fine. You get theta as this. And now it wants to work out the vertical height of this pyramid, which is, of course, this length here. And to do that, we can literally just do some SOHCAHTOA because this is a 90-degree angle. We can do sine of theta is this over root 14. If I call that h, then we can just say sine of 58.1 times root 14 is h, and we get this as our answer there. Question number 10 then, so show this thing. So this is clearly 3 times 9 minus 3x, or to the power minus a half, because it's the square root, so it's a half, it's on the bottom, so it's a minus. And now, of course, I can factorize out 3 from both of those things, sorry, a 9 from both of those things, even though it feels less natural. And I've got a product inside of this power here, so distribute the power out to each of the two things, like this. 9 to the power minus a half is a third. The third cancels with the 3, and you're just left with the thing that they wanted you to show, which is good. Hence, expand this up to x3. The formula is in the formula book, so we're just going to have 1 to start with, plus n, which is minus half, times x, and x is minus x over 3. So every time you see an x in this formula, use minus as x over 3. And then the next one will be a half into a half minus 1, which is minus 3 over 2 factorial into minus x over 3 all squared. And then the next one is just this with an n minus 2 here and a 3 factorial here, which is exactly what this is, and then a x cubed over here as well. Type all of these results into the calculator and you get this, and that's going to be those 3 marks done there. Now f of x equals this thing, expand 3f of x. So 3f of x is just going to be 3 times this, which is, I could write, I guess, as this bit times 3 over this bit. But we already just expanded out this. We said this expansion was this here, so that's going to be this here. And now we can do 1 times all of these things for this, and then we can do 2x times all of these things, except for this one, because that'll make an x to the 4 term, which we don't care about, because it's up to x to the 3. And then we combine these two things together, and we end up with this here, up 2x cubed. Now just be careful in this very last bit, because this is not, well, this is f of x here, but this expansion is not f of x. This is 3f of x. So let's put this expansion into here, but divide everything by 3 as well, because of this 3 of x, f of x here. Bring the third out, and then you can just integrate this stuff here. And then you can put the numbers in, literally just type all of this in a calculator with this, and then minus brackets all this, and you eventually get this as your answer. Pretty boring stuff. Anyway, this one here, so many ways you could go about doing this, but I figured we're going to need a picture eventually. So I just drew a picture straight away. This is minus 3 minus 5. This is 7, 5 up here. And yeah, the gradient here, well, it's 10 across clearly, and it's 10 up from minus 3 to 7 and from minus 5 to 5. Therefore, the gradient is 1. And then just doing y minus y1 equals mx minus x1 with whichever point you want. I just chose this one here. And you get this, which rearranges to be this. I really hope it does at least. And we have our answer. Point C has coordinates P1, where P is less than 0. So it's over here somewhere, because P is the x-coordinate. So let's put it somewhere. So the y-coordinate is 1, so it's sort of along this horizontal line here. And where could we put that such that we make a 90-degree angle between A and that point and B and that point? And after a bit of thinking, I figured over here would be kind of reasonable, because that looks a bit like a 90. So P is probably less than minus 3, but let's not take that for granted. Anyway, to do this, what we'll do is we'll work out the gradient of this line here, which is, okay, so if we get some gradients out, the change in y is 4, and the change in x, now be careful how you write this, it's got 7 to go across here, and then it's got another p to go across here. Now, if I just put 7 plus p, because I know p is negative, 7 plus p would, if p was, well, I know p is minus 5. So if I put 7 plus p, I'd be actually doing 7 plus minus 5, which is 2, and this distance is much bigger than 2. So I actually need to write 7 minus p, because now 7 minus minus 5 will get me 12, which will be the actual distance here. So that's why I did that. This one's even more fiddly to get right. I mean, there are efficient ways of doing this, but I figured just being intelligent about it is reasonable. Now, I've written it like this. Why have I done this? Well, the minus is here because this is clearly a negative gradient. So that's just what I said to start with. And now the y change is 6. That's fairly clear and obvious. Now, what about the x change? Well, again, consider the fact that p is a negative. I just want this little distance here. So what I chose to do was I chose to do minus 3. If I do minus 3 plus p, like minus 3 plus minus 5 is minus 8, and that's a much bigger change than I want. So therefore, minus 3 minus p, like minus 3 minus minus 5 is minus 3 plus 5, which is 2. And that's a nice little distance between minus 3 and minus 5. So I figured I took this answer here, and I just made this work to what I knew it would need to look like. That's what I did with these two things. So yeah, if I know p is minus 5, I know these two gradients are going to be correct. So use the answer to help you, not just to check your work, but also, of course, if you need to set anything up complicated, just use it to help you make sure you set up the right thing. Anyway, we know these two things meet at right angles, so therefore this equals this as long as I times this by a negative and flip it over. Of course, the negatives will cancel. I flip this one over like this. These brackets are a bit awkward, but okay. Anyway, cancel out those two negatives and then cross multiply. 24 over here this times by this equals this quadratic. Take away 24 to get this, and tidy up the other things. This factorizes, and so the answers are -5 and 9, but you're told p is negative, and we're also told p is -5, so I know that I'm definitely correct about that. Anyway, D is some point where B, so this is B and this was C. BCD is a straight line, so D is on this line somewhere, such that C, which is this one, divides BD, B to D in the ratio of 4 to 3. So I think just about they've given me enough to say that this is the 4 parts bit and this is the 3 parts bit, because it goes B to D in ratio 4 to 3. So the 4 is close to the B and the 3 is close to the D. I think they could have been more clear about that, but who really cares? We have a distance down of 4 here and a distance across of 12. So 4 parts is 4 down, 12 across. So therefore 1 part is 1 down and 3 across. And therefore 3 parts is 3 down and 9 across. So let's go 3 down from here to get to -2 and 9 across to get to -14. And that will be our coordinate. Find the length AC. So this one was A, remember, and this one was C. So the length of this is clearly just 2 across squared plus 6 up squared, square rooted. Just doing Pythagoras, we get this. Hence or otherwise, find the area of the triangle ABD. So A is here, B is there, D is there. Now this is a right angle, remember, so I can just do half times base times perpendicular height. That's the perpendicular height, I just worked it out. What's the base? Well, it's the distance from this coordinate to this one. This coordinate was this, remember, so the x change is 21 from -14 to 7, and the y change from 5 to -2 is 7, so that's going to be BD is 21 squared across here, plus 7 squared up here, square rooted, which is this, and then of course I can just do that length times this length times a half, because there's a 90-degree angle here, as we've said, which is this. That's the whole paper. Thanks for watching.